All right, let's finish up the 4-1 notes, and we're going to start with 4-2 notes. We'll take notes like this on occasion. Just kind of tune in, pause the video where you need to, and answer the prompts, and we'll all kind of get some good notes. So yesterday, some of us got this in our notes. Example, working with Babylonian system. In notes, before this section, we talked about how our system is, if we had a 3 here and a 4 here and a 7 here. So this is just an example. Our system would be 3 times 1, 4 times 10, and 7 times 100. And we understood that that was 743. So the Babylonian system is very similar. And we wrote this 100 sometimes as 10 squared. So instead of having 10s, the Babylonian system has 60s. But other than that, it's really very similar. So that's how this example works. This number from your notes represents the number 1. So there's 160 squared here. That number represents 10, 60 to the first, and then 2 1s. And just like ours, where we changed it to a 100, they actually do the 60 squared. 1 times 3600, 10 times 60, plus 2 1s. And we add those numbers up and we get 4,202. So let's take a look at what that would look like in an example. This right here, the carets represent 1s. So I have 1 and a 1, which represents a 2. I have a 10 and a 1, which represents an 11. And I have 2 10s and 2 1s, which would represent the number 22. Now, those don't just represent 2s, 11s, and 22s. Just like our 4, 7, and 3 didn't represent a 4, it represented 4 100s. This represents 22 1s. This represents 11 60s. And this represents 2 60 squareds. So we're definitely going to need a calculator. 2 times 60 squared is 7,200. 660, 22. And we add all those up, and we get 7,882. So this positional system right here represents 782. And again, pause the video, go back, try it out. The last thing from 4.2 was the Mayan numeration system. Now, you want to pause the video and copy this entire chart into your notebook. So theirs is a base of 20. So they repeat when they get to 20. So again, I'll use our example of 743. 3 1s, 4 10s, 7 10 squareds, ... We understand that. Now it's just a matter of putting different symbols for numbers with a different base. So if we have this in our notebook, I'm going to switch to the next slide and we're going to try an example. I usually start from the bottom. 2 lines, each line represents a 5 plus 2 would be 7. 1 line and 2, oh sorry, that's a 12. 1 line and a 2 is a 7, I was ahead of myself. That's a 0, and this would be 14. But again, those don't just represent those numbers. This is 1s, this is 20s, this is 18 times 20, and this is 18 times 20 squared. So those represent, like, once you get a couple of commas past in Mayan, they represent some large numbers. So we do that multiplication, got to have a calculator. 14 times 18 times 20 squared is 100,800. 360. Nope, that's not 360, that's going to be a 0. 140 and 12. And we should get 1,952. There it is. 100,952.